Hello good people, I'm going to talk about isomers. Previously I spoke about molecular formulas and structural formulas as well as condensed structural formulas and skeletal formulas. You might be wondering, why do we bother? Why not just stick with a molecular formula and be done with it? Well, one reason that I mentioned previously was that molecular formulas do not tell us anything about connectivity. But another is the existence of isomers. Isomers have the same molecular formula, but a different structural formula. To make things interesting, and because this is chemistry, we can divide isomers into two main types: constitutional isomers and stereoisomers. Constitutional isomers have the same number of atoms, but they are connected differently. Here is a molecular formula, C4H10. How can these 14 atoms be connected without breaking any of the building block rules? Remember, hydrogen can only have one bond and carbon needs to have 4 bonds. One way is to create butane. And here is its structural formula. You have encountered it before. As a reminder, here is the condensed structural formula of butane and also its skeletal formula. This is not the only way we can arrange these atoms. Here is the second arrangement. Note that we haven't broken any rules. All of the hydrogens have 1 bond and all of the carbons have 4 bonds. What would the condensed structural formula of this compound look like? Let me divide it into carbon groups as I have done before. I have a methyl group here at the start, I have a methyl group here at the end if you like, and also a methyl group at the top. This leaves me with this carbon group in the middle. And so if I was to write the condensed structural formula, I would have CH3, the methyl group at the start, then I would have this CH group. And now I need to indicate that this CH group has 2 methyl group attached to it. I have this CH3 on the top and this CH3 on the right. So the way we do that, we write CH3 and then we place it in a bracket. That could be the CH3 on the top, and then we place in the final methyl group. This CH group has its own name. Recall, CH3 is a methyl, CH2 methylene, and CH is known as methyne group. Next thing to note is that this is not the only way we could write out the condensed structural formula. I could say that I have a CH group that is attached to 3 methyl groups, which means I could write CH3, place it in a bracket, and then place a 3 in subscript. This might be a bit frustrating, but I would like to remind you once again that learning organic chemistry initially is like learning another language. And when it comes to languages, we can use several different words or synonyms to describe the same situation. I could say something is great, or something is fantastic, or something is awesome. It means the same thing. So similar thing here. These 2 condensed structural formulas convey the same message using a different word. What about its skeletal formula? What is the longest continuous chain? It is these 3 carbons. So I'm going to draw the skeletal formula for them. 1 carbon, 2, 3. The carbon in the middle is attached to another methyl group, so here it is. As I have mentioned earlier, the compound at the top you have already met. We've called it butane. But now we need to distinguish it from the compound at the bottom. The compound at the top is known as N-butane, where N stands for normal. And the compound down here is known as isobutane. The differences in structure affect the physical properties of these compounds. For example, the boiling points. N-butane boils at -1 degree Celsius or thereabout, while isobutane has a lower boiling point at -12 degrees. In summary, isomers are molecules that have the same molecular formula but a different structural formula. Their atoms are arranged differently. The change in the arrangement of atoms is not trivial. It has an effect on physical and chemical properties of these compounds, but more on that later. That is all for now, and I will see you on the flip side.